what are diesel systems and what is the configuration of the diesel system, and all those things we have seen. Right, now we'll be seeing in the similar way a photovoltaic system. You people all have I guess you people have already studied this solar energy conversion systems, right? In that solar energy conversion systems, you know that uh, sun is a form of electricity. Sorry, is sun is a form of source through which we can get electricity, right? So there are different ways in which the solar energy can be tapped. So basically there are two types of solar energy systems. First one is called as the solar thermal systems, and again we have the solar PV systems. In the solar thermal systems, we'll be tapping the heat energy from the sun. Whereas in solar photovoltaic systems, that is the PV systems, will be tapping the light energy of the sun. So either way, we are going to take some form of energy, either it is a heat energy or light energy, and converting it into an appropriate form of energy for us to use. If we go for the thermal systems, that is a solar thermal systems, there we'll be seeing that the solar thermal systems have a wide range of applications. They can be used to produce electricity, as well as they can be used to provide cooling for buildings or houses or anything, and in the same manner they can be used for heating systems, that is the hot water systems and all those systems. So those are the basic applications or some of the applications for the solar thermal energy. Whereas coming to the solar photovoltaic systems, as the name itself indicates, photovoltaic, that means there will be a potential difference that will be present between the two ends of the solar cell because of the light energy. This solar photovoltaic systems are basically dependent on the type of material we are using for this preparation of the solar cell and all those things. We know that there are three types of materials present in our periodic table. Basically, we call them as what do you say, insulators, conductors, insulators, and semiconductors, right? So based upon the nature through which they react to electricity, we name them as conductors, insulators, and semiconductors. In those three devices, in those three divisions, when we come to the semiconductors, these have a special property. In this, what is the special property while coming to the semiconductors means, semiconductors, in semiconductors, they act according to the different conditions, right? If we are providing any external help to the semiconductors, they act as a conductor. If there is no external help, they act as a insulator. So based upon whether we are giving the external help or not, these materials, semiconductor materials, act differently in different situations. Basing this as our what do you say, primary concern or primary property, we have designed this photovoltaic systems. As you can see, this is the basic constructional feature of a PV cell. Here you can see that there is a P layer and there is an N layer. P layer we know, right? P layer is the layer where holes are the majority charge carriers, whereas N layer is the layer where electrons are the majority charge carriers. Uh, you know that just we are saying that holes or electrons are the majority charge carriers means those are not only the carriers present in that particular material. We will be having, if it is a p layer junction, p junction, sorry, p material, then we'll be having, along with the holes, we'll be having some electrons will be called as a minority charge carriers, whereas because of the nature of, that is the amount of holes present, we are calling them as the majority charge carriers, whereas the electrons will be very less, and these electrons, even though they are less, they will be present, so we are calling them as the minority charge carriers. These in case of an n-type material, we'll be having electrons as are majority charge carriers, whereas the holes as are minority charge carriers. These are the things which we already know, right? So these two, when we put together, then something different happens. What will happen means, basically there will be at the junction of this p type material and n type material, we'll be having a barrier, that is the potential barrier formed. What is this potential barrier means? The potential barrier is nothing but the area where there is no charge at all, there are no charge carriers at all. Okay, so for example, if it is from p layer, there the holes which are crossing into the n layer, or the electrons which are crossing into the p layer, they will be leaving some constant, what do you say, constant charges, and then those constant charges constitute the total that barrier, potential barrier. And now in order for these electrons or holes to move from one layer to other layer, that is from p layer to n layer or from n layer to p layer, we need to give the material an extra boost. We are giving that extra boost in different forms. Okay, for example, if you are going for pressure as the extra boost, then it is called as an piezoelectric crystal. If you are going for heat, then thermal, that is the transducer. If you are having if in this case we are having light, so we are using light energy, that is the photon energy which is there. The photons which are there in the light will be delivering the energy to this whatever the carriers are there, whether it might be a majority charge carriers or the minority charge carriers, and allows the carriers to move beyond this potential barrier. That is the basic concept through which the photovoltaic system has been built. Okay, so here you can see the basic features, that basic construction of a PV cell. Here you can see a P layer, an N layer, and a PN junction, as we have discussed. And then on this PN junction, we will be having different layers which will be protecting the cell, the solar cell. Okay, so basically the potential, there will be a potential present between this p layer and n layer. Okay, so the terminals of the p layer and n layer are connected to the load as shown in the diagram, and then we'll be having a anti-reflecting reflection coating. So basically when you are going for this type of construction, this type of solar cell construction, the light may hit it and then it may just go out of it, right? Reflection property might happen. So in order to trap the light inside the solar cell such that we may get maximum amount of electricity out of it, maximum benefit out of it, we'll be giving it a anti-reflection coating, such that even if the light enters the solar cell, it will not be leaving the solar cell because of the anti-reflection coating. And again we have an adhesive, just to adhesive is nothing but the gum type thing, and then we have the glass cover. So you, in order to protect the total case in total solar cell, we'll be having a glass cover which will be covering the whole solar cell arrangement. So this is how the basic construction of a solar cell is. Now, while coming next thing we need to know, which we need to know, is the equivalent circuit of the solar cell. So whenever we are going for any material, whenever we are going for any machine, or whenever we are going for anything, we need to know its equivalent circuit, because we need to calculate different parameters, we need to represent it into a circuit, right? In order to represent the total system into a circuit, we will be going for this process called this term called as the equivalent circuit of the system. Here what we'll be doing is we'll be just representing the system in the known elements, right? So here we are representing the total PV cell in the known elements like diode. We are using a diode as well as two resistors. So using this we are just representing the total solar cell. Okay, this is the equivalent circuit of the solar cell. Okay, and after that we basically in any what do you say, in any machine or in any device, we will be having some important parameters which will be governing the total nature of that particular element. Okay, so those parameters for this particular solar cell are basically, there are like how many parameters? Four parameters basically. Okay, the first parameter is called as the short circuit current, that is the I, or the out, which we have which we, for which that equation is given right here. And then we have the second one, that is the output voltage. Okay, then we have another one which are nothing but the output characteristics, and then we have the last one which is called as a fill factor. So basic upon these four parameters, we'll be judging how well the solar cell is being designed. So we need to make sure that everything, whatever the solar cell might be, we need to make sure that these parameters have been designed correctly. If you are designing these parameters correctly, then you will be having an optimum solar cell. So these parameters, here he has given the equations, and here is showing us the different characteristics which we need to make sure for our system, solar system. So these are the things. Okay, next is next, even before going to this particular, okay, even before understanding this particular diagram, we need to understand that solar energy is very unpredictable, right? Solar, the sun might shine very much, very bright on some days, sun might shine very low on some other days, right? So in order to optimize, or in order to make sure that whatever the condition might be, we, in order to make sure that we are getting maximum amount of benefit from sun, we need to understand the points where the maximum power is being produced. Okay, so this type of understanding, or this type of analysis, is called as the maximum power point tracking. Okay, so there are different methods in which this maximum power point tracking can be done. That also you people might have studied in your solar energy conversion systems. So basically what happens here means, whenever you know at what direction, if you put the simple example I'll give you, not even, let's not go into uh, depth of all these things. So if you just understand that there is, if you are putting a solar PV array, let us say that there is a solar PV array and we are going to arrange that solar PV array in a particular direction, let us say in the east direction. So we know that the sun rises in the east in the morning, and then it reaches the um, what do you say, it reaches the exactly above us, right? It reaches the exactly above us position at the noon, and then it will set in the west. We know this, right? So now, in order to get the maximum amount of solar energy, we need to make sure that our PV array is facing east in the morning, and then it should be flat on in the afternoon, and then it should be facing west in the evening. So in this optimal position, if you're just moving the solar PV in this direction, then we can ensure that it has a little amount of, a little better way of getting the solar energy. That is a little better way of tapping the solar energy, right? This is the basic understanding. Now just imagine if the PV array can move along the sun. If just imagine if the PV array can track the sun's movement and then move along the sun's movement, then you will get maximum amount of solar energy. Then you can trap maximum amount of solar energy, and by the trapping of the maximum amount of solar energy, you will be getting maximum amount of electricity, right? So just by understanding this simple concept, you can understand that there is a need for the tracking, sun tracking, right? So for that we are having this MPPT algorithms or MPPT trackers or anything. Okay, so if you just look at this diagram, here is showing there's a standalone PV power system with a MPPT converter and battery backup. So in this diagram, it is a standalone system. So you will not be having a utility grid or something like that. You will be having directly a load. This this setup can, if we can just arrange this setup in our house, we can just tap the solar energy and directly feed to the loads, that is feed to our house itself. We need not to depend upon the utility grid or anything. So this is how the total system is. Okay, so here let us see what are the different parts that are present. So PV array, okay, we are having a PV array, we are having a diode. Diode just ensures that our electricity is just moving from in one direction rather than a bidirectional. This way we are having a unidirectional flow of current. So again we have a DC to DC converter depending upon different types of loads. That is, if you are having only DC loads, then DC to DC converter will help you. If you are having AC loads, then we might have to add a DC to AC converter. Okay, so basically we have a DC to DC converter. As it is a standalone PV system, we can assume that whatever the loads are there, those are of DC type. Okay, again we have a maximum power point tracker. That is, we are just understanding where the maximum power can be tapped, at which angle the maximum power can be tapped, or at which direction the maximum power can be tapped, and then we are going to move the PV array according to that maximum power point towards the maximum power point. And again we have a PWM signal generator, which will be just controlling how the DC to DC converter is being operated. Okay, and again we have charge bar discharge converters. So basically here, as it is an battery, as the system has a battery backup, we can charge the battery when the when the solar energy is present, and then we can just use that charged battery to power our loads whenever there is no solar energy. So we need to have both of these charge as well as discharge converters, so such that whenever we need to charge the battery, the current will be moving in one direction. Whenever we need to discharge, the current will be moving in the opposite direction. Again we have a battery management system for this, on and off of the, whether it has to be in the charging mode or whether it has to be in the discharging mode, how the converter should be present. We are having a battery management system. In this battery management system, we'll also be having different inputs, like how much what do you say, power has been consumed and how much power is present in the battery bank, etc., all those things. Okay, so this is a standalone PV power system with a MPPT converter and as well as a battery backup. So this is how the total construction will be. Okay, next is hybrid systems. Till now we have seen what is diesel system as well as what is photovoltaic system. Now we will be seeing how these two can be, how the configuration will be if any two combinations of this is happening. That is wind diesel system without battery. Okay, so this is the single line diagram of a wind diesel hybrid power system. You can see directly here the load is present in the center, and then we are having a diesel sector in the left side, and then we are having a wind turbine on your right side. Simply what we are doing, we are just tapping both the energies and we are giving it to a bus bar where it is connected to a load directly. Okay, so here we have another thing called as the dump load. Dump load is nothing but the load, it is like a dummy load. Okay, it is like a dummy load where if the machines needs something to discharge into, we'll be going for the dump load. Okay, so this is the without battery system and this is the with battery system. Here he has given the single line diagram. He's just giving us a generic block diagram here. So wind generator, we have a rectifier, we have an inverter, and again this is connected. Simple things, not in a very, complicated manner. He is just giving us the block diagram of how the system might be. We'll be having a wind generator, and after the wind generator, we'll be having a rectifier where it rectifies whatever the system is there. And then after the rectifier, there will be an inverter such that it can be directly connected to the load. Otherwise, we can, even before the inverter is being introduced, we can just charge a battery. Okay, so we'll be having a battery backup. Again, from the diesel generator, as it is, directly giving us the AC voltages or AC currents. Now it can be directly connected to the load, or if you want to charge the battery bank, then you will be here we need another parameter, which is the rectifier. So this is a configuration of the wind diesel system with battery. Okay, and the last topic is the wind photovoltaic system. Here also you can see it is rather simple, right? We'll be connecting both the wind as well as the photovoltaic systems, and this will be having a control unit which will be transferring the what do you say power, transferring the mode of electricity production. That is whether we can use the wind turbine systems or PV array systems. Sorry, PV array systems, depending upon our requirement and everything. So, and as we have already seen, it is preferred to go for the wind systems, as PV systems is much more what do you say costlier. Per unit cost of the wind energy generated system will be, wind energy generation will be a little less than the photovoltaic array. That is the per unit value, per unit cost of the photovoltaic generation. So we'll be preferably going for the wind turbine or the wind generation, and then whenever the wind generation is not possible, then we'll go for the PV generation. So we'll be having a control unit just to transfer the sources, the mode of electricity production, whether we are going for the wind turbine or PV array. Just to ensure this smooth transition, we are having a control unit. Okay, and again we'll be having a what do you say DC to AC converters, such that it will go for the loads. We need to provide if you are having a DC load, it's okay, you can just tap the energy directly and then you can just give it to the DC load. If you are having an AC load, we need to have a DC to AC converter. And we'll be having a battery here also. This system is also having a battery, such that wherever there is an excess amount of excess amount of any energy, then we can just convert that energy into electricity, and then we'll just store that in a battery, and then whenever there is an absence of any source of energy, we can just use the electricity present in the battery. So this is how the total wind photovoltaic system is being constructed. Okay, so